Hello, this is the Algebra A Graphing Systems review for their test coming up this week. So let's get started. So let's find the equation of each of the lines. So remember, for equations, we want slope-intercept form, which is like this. So we need to have our slope, okay, which they actually give us here. So we're already halfway there. We already know this is going to be y equals negative 2x. But then we also need the b, which is the y-intercept. So that's the part we don't know. So we go here and just going to use my slope-intercept form, right, and plug in what we know. So I know m is negative 2, right? We also know x is negative 4, and we know y is 3. So the left side will be 3. And then, of course, the b is what we're trying to find out, so we don't know that. So then we can go solve this. So we have 3 equals negative 2 times negative 4 is positive 8. And now we can subtract 8 on both sides. So we get negative 5 equals b. So I know my equation is y equals negative 2x minus 5. Let's do another one just like that. Once again, they give us the slope, so to start off with, I'm already halfway there. I know the slope is 1/2, but I don't know my y-intercept. So let's plug everything in. Got y equals mx plus b. M is 1/2. X is 8. Don't know the b. And my y is negative 1. So it's going to be negative 1 equals. Okay, just solve this. Negative 1 equals half of 8 is 4. And subtract 4 on both sides. And looks like, again, we get the same y-intercept, negative 5. So we'll have y equals 1/2 x minus 5. So those are two problems where we give you the slope and you're kind of halfway done with the problem. On these next ones, starting on number 3, right down here, right, they don't give you the slope. So we have to find both, right? We have to find both the slope and the y-intercept, figure out what both those numbers are. Alright, so the slope, recall there's several ways of doing this. One of them is a formula where you put the two y's on the top, 5 minus 11 on top, and 2 minus 4 on the bottom. So the x's go on the bottom and the y's go on top. Rise over run. Solve this, we get 5 minus 11 is negative 6. And 2 minus 4 is negative 2. So negative 6 divided by negative 2 is positive 3. So now I'm halfway there. I know it's going to be y equals 3x, but I still don't know the y-intercept. So now we're going to do the same step we did before in 1 and 2, using 3 as the slope. So we have y equals mx plus b. I put in my positive 3 for the slope, and I'm going to use either one of these. Okay, I'm going to use the 4 for x and the 11 for y. So 4 for the x and my 11 for the y. So we'll have 11 equals 3 times 4 is 12. Right, subtract 12 on both sides. And 11 minus 12 is negative 1. So my final answer will be y equals 3x minus 1. I really need plus there. Just y equals 3x minus 1. Final answer. Okay, let's do one more just like that where we have to do the slope and we have to do the y-intercept. So first the slope. Now I'm going to use the other method we've done. That's using a table. So I just put both the x and the y in here. 3 comma 8, negative 3 comma 8, and 2 comma negative 2. Now how far is it to go from 8 down to negative 2? Right? That'd be, we'd have to go down 10. Right? We have to go down 8 just to get to 0, and then 2 more to get to negative 2. So that's down 10. Same thing here. How much do we have to go up by to go from negative 3 to positive 2? That'd be up 5. So my slope will be rise over run, so it'll be negative 10 over 5. Always the y over the x. That equals negative 2. So this first part of the answer, if I'm plugging everything in, I have my negative 2 for the slope. So negative 2, but I do not know what the y-intercept is. So let's figure that out. So we have y equals mx plus b. And I'm going to use this x and this y. There's x is 2, y is negative 2. So negative 2 is the y. The slope is also negative 2, and the x is positive 2. Lots of 2's. So we have negative 2 equals negative 4 plus b. I'm going to add 4 to both sides. So we'll get 2 equals b. So my final equation would be y equals negative 2x plus 2. Next, we're going to solve by graphing. So let's go ahead and graph both of these. Let's see here. Remember, this is going to be negative 3 over 1. So that's down 3, right 1. Okay, so we're going to start at 5. 1, 2, 3, 4, 5. And down 3, right 1. I'll do that a few times. And use a straight edge because your answer is where these intersect, so you want to use straight lines. There you go. And let's do the second one. Remember that when there's no slope given, it's automatically a 1x. And the run is also 1, so it's really 1 over 1x plus 1. So start here at 1, and we can see they intersect right here. And so move it further out. And there we go. Okay, so we haven't gotten the answer yet. Remember, the answer is where they intersect. So this is at the x, they intersect at 1. So it's going to be 1 comma. And then the y is at positive 2. So y is 2. So the answer would be 1 comma 2. Let's do a few more. Number 6. A little more straightforward. Y equals negative 3. So we can only go through the y-axis at negative 3. So this is the y-axis. Negative 3 is right here. And we're not allowed to cross the x-axis because we don't have an x variable. So my answer is just horizontal line. That's the only way we can go through y at negative 3 and not cross the x-axis at all. Similarly, for here we have x equals 2, so we can only go through the x-axis at positive 2, and we're not allowed to go through the y-axis because we don't have a y variable. So that is a vertical line. And with no surprise, with x equals 2 and y equals negative 3, they intersect at 2 comma negative 3. Do one more that's kind of like that. Alright, this one is similar. We're going to start at x equals 2, so x at positive 2, right here. Cannot cross the y-axis, so let's go straight vertical. Alright. And then we have this other line. We have a slope of 3 over 1 starting at negative 2. So start at negative 2, go up 3 over 1. There's our intersection, our answer. Do it a few more times, and then use a straight edge for that. So it looks like our answer is going to be right here. So it's going to be 2. No surprise, we have x equals 2, so the x is 2 in the answer. And it's up 1, 2, 3, and 4. There we go. 2, 4 for our answer. Alright, let's look at 8 and 9. Very similar, just see where they intersect, but we're going to have to do some solving on a few of these. First one we don't. So we're going to graph, let's see here, start at -1, and we're going to go down 3 and right 4. Down 3, 1, 2, 3, right 4, 1, 2, 3, 4. And let's do that a few times. Okay, use straight edge. There we go. But the second one we're going to have to actually solve for. So we're going to do minus 3x on both sides. So we get 4y is negative 3x plus 12. Divide everything by 4. Y equals negative 3x over 4 and then plus 3. So we're going to start at positive 3. 1, 2, 3. And also go down 3 over 4. And 1, 2, 3. 1, 2, 3, 4. And you can see that we have some parallel lines. And since the answer is where these intersect, and they never intersect, we have no answer, so no solution. Okay. Which is the same as no intersection. Okay, let's try a few more. These ones we have to solve all the way for, so let me solve this one first. 3x plus 6y equals 6. Let's subtract 3x. And then I'm going to divide by 6. So I'll have y equals negative 1/2. 3 over 6 reduces to negative 1/2 x. And 6 divided by 6 is just 1. So start at 1, and we'll go down 1 over 2. Do that a few times. There we go. And let's do the second one now. Just need to subtract x on both sides here. We'll get 2y equals negative x plus 2, and divide everything by 2. Y equals negative 1/2 x plus 1. Now, look at those. Those are actually the exact same line. So if you graph here, and you would get the exact same line. Wow, look at that. So if the answer is where these intersect, where do they intersect? Well, it's every single point they intersect. They overlap everywhere. Okay, so that means every number is an answer. So you can say all real numbers. That's one way of saying it. Okay, or infinite solutions. Another way of saying it, but yeah, the two lines happen to be the exact same line. Okay, let's look at one more. Let's do this one, the 9x plus 3y equals 6. Subtract 9x both sides, and we're going to end up dividing by 3 everywhere as well. Divide by 3, divide by 3. So we have y equals negative 9 divided by 3 is negative 3x. 6 divided by 3 is 2. So start at 2. And once again, we're going down 3 and right 1. So we did this one earlier. Okay, use a straight edge. And let's do the second one. We're going to subtract 4x on both sides. So negative 2y equals negative 4x minus 4. Divide everything by negative 2. So we'll have negative over negative, that'll be positive 2. So y equals 2x. Negative 4 divided by negative 2 is positive 2 as well. So we're going to start at positive 2 here and go up 2 over 1. We can already see the answers where these were going to intersect, so that was our first y-intercept with our answer. Okay, so we're intersecting at right here, which is 0, 2. All right, let's go down to 11 and 12 and 13, which now they are inequalities. So inequalities means we have shading. Okay, we got shading to do. So let's give this a try. We start at 5. 1, 2, 3, 4, 5. We're going to go down 3 and right 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay, and right here there's no line underneath, so we're going to have to do a dashed line here. I'll make this a dashed line. And it's pointing greater than. Remember, left is less than, so if it's pointing right, it's greater than or pointed, shaded up. So we're going to shade everything that's up. Like that. Make sure you don't go too close to the dotted line because you don't want to cover up the fact that it is a dotted or dashed line. Okay, starting, let's see here. Number 12, very similar. Got to graph this. It's no line underneath, so we know it's a dashed line. There's only a y variable, so I have to start at y equals negative 2. And I cannot cross the x-axis, which means my line would have to be horizontal. And this one is left, right? It's pointed left, so it's less than. So that's shaded down. Less is down. So everything that's shaded down. And one more that we have to solve for. 13. We have, let's see here, subtract 3x on both sides. So that's negative y less than or equal to negative 3x plus 6. And then let's go ahead and divide by negative 1. And of course, anytime you divide by a negative, we must flip that sign. So we're going to have y greater than now to 3x minus 6. And that'd be 3 over 1. So we're going to start at negative 6. 1, 2, 3, 4, 5, 6. And go up 3 right 1. 1, 2, 3 over 1. Do that a few times. And this one's a solid line because we do have an equal to on there. So we're going to go solid line. And we're going to shade greater than, above. So any point on the line, go straight up, and that's the side that we shade. So we need to shade all of this. There we go. All right, let's start graphing the systems now. So systems, we got 2 inequalities to graph, and then the answer is where the shading overlaps. Shading has to overlap. Let's graph this first one. Start at negative 3. 1, 2, 3. And you're going to go up 2, right 1. Slope of 2, same as 2 over 1. Okay. This is a solid line. Line underneath, so we're going to do a solid line. Okay. Now let's graph this one. We got x, so only the x-axis. We're going to go to negative 1 here. Let's see, that's positive 1. Negative 1's right here. So So we have a vertical line, which is going to be a dashed line because there's no line underneath, just greater than. So here we go. Alright, now you're going to need to do a little bit of erasing when you're doing this. So first I want to shade everything that is above, right, greater than the blue line. Everything above the blue line would be all of this. It's all above the blue line. Okay. And then I want to see where that overlaps with everything that is greater than -1. So that would be to the right, all of this. Okay. And just look at that and notice how the shading overlaps right here. So what you guys would do is start erasing this part and this part. Right? You would erase all of this and just keep where it overlaps. I'm actually going to undo it and then reshade that one area. So this part right here is the only part that should be shaded. All right, let's do a few more. Let's start at -1. And we're going to go up 2, right 3. Right, and this is a dashed line. And next we're going to start at 5. Go up 5. 1, 2, 3, 4, 5. And we're going to go down 3 and right 4. 1, 2, 3, and right 4. 1, 2, 3, 4. Do it again. Down 3, right 4. All right. This is also a dashed line. So we've got many dashed lines here. There we go. Okay. And I want to shade above the red line, so that's everything above here. And I want to shade below the blue line. So below the blue line would be all this. And there you can see the shading overlaps right here in this quadrant. So I want to, if you have an eraser, go ahead and erase this part and erase this part, and you're going to keep this. Alright, and keep this part. So it's above the red line, greater than the red line, but less than the blue line, below the blue line. Let's do a few more of these. Still have the special cases we got to get to. Let's practice one more. Let's do y is greater than -3, so we know that's going to be down here, y-axis, -3. Okay, once again, a dashed line. And the top one here, we're going to have to solve that one for y. So we got -5x, -5x, 2y, less than -5x plus 4. Divide everything by 2. Okay, so we're going to start at +2. We're going to go down 5, right 2. So that's down, and that means right. Down 5 and right 2. 2, 3, 4, 5. 1, 2. There we go. What's your dots on there? Alright, and this is also a dashed line, so dash that line. There we go. And let's do some shading. So I want to do below the red line. Everything below the red line. But also I want to do greater than above the blue line. Above the blue line, that's all of this. So my answer would be just this quadrant right here, shade all that in. Or just erase those two parts. There we go. Okay, let's do a few more. Go look at the special cases. You can kind of tell. Let's go 17. Yeah, you can kind of tell. See how the inequalities are very similar to each other. You can kind of tell that those will come out to be parallel. But just remember that parallel does not necessarily mean no solution. So the first one here, I'm going to subtract x on both sides. So I'll have y is greater than negative x minus 2. And I'm going to do the same thing on the second one. Subtract both sides. So I'll have negative x plus 3. Let's go ahead and graph these. Both dotted lines, both same slope, just different y-intercepts. So start at negative 2, down 1, 2. I'm going to go down 1, right 1. An easy slope there. And it's going to go this way as well. Okay, that's one of them. The next one will be starting at 3. 1, 1, 2, 3. And same slope, down 1, right 1. So as we kind of suspected from the beginning, do have parallel lines. There we go. Now the question is, how does the shading overlap, or does it at all? So we want to go below the red line. That's all this is below the red line. Okay. And then we want to go above, right, above the blue line. So all this and above. And we can see the shading overlaps right between the two lines. So go ahead and erase all this and erase all this. Keep between the two lines. Just right here. There we go. Alright, let's try another with the parallel lines. This time you'll notice it'd be a little bit more work to solve, so get over here. So we have 4x minus 3y is greater than or equal to 6. So do some subtracting. And also do some dividing by a negative, so I will need to flip the inequality sign. We'll have y is less than or equal to positive 4 over 3x minus 2. Basically the same steps here for the second one. The only thing different is this negative 3 on the end. So once again, subtract 4x. Negative 3x less than or equal to negative 4x minus 3. Divide everything by a negative once again and get switch the sign. So we're going to have greater than or equal to 4 over 3x and plus 1. Let's go ahead and graph both of those. So we'll start at negative 2. We're going to go up 3, no, up 4 and right 3. Up 4 and right 3. 2, 4, there we go. 4, there we go. And this is a dashed line. Okay. Next we have here, I'm going to start at 1, positive 1, and do the same thing, go up 4 over 3. 1, 2, 4, go, 2, 4. This is also a dashed line. No, these are both. Wait a minute. No, these are both solid lines. Get that right. So yeah, these are both solid lines. Yeah, there's a line underneath both those symbols. I just could not see it. Let's try this again. There we go. Made that right. Okay, so we want to shade now above the blue line, no, less than the blue line, so down here, below the blue line. and I want to do above the red line. So where does the shading overlap? And you can see it doesn't. So there are no solutions because the answer is only where the shading overlaps, so we have to erase all the shading and write no solution. No shading overlaps, so there's no solution. So keep in mind that with inequalities, parallel lines does not necessarily mean no solution. It depends whether the shading overlaps. It could be either way. Okay, one more. First one, pretty straightforward. Y at -1, and we got a dashed line. Slope is 0. We're not going up and over. Okay. And then here, subtract 3x. Okay. -2y greater than 3x plus 4. Dividing by a negative, so flip that sign for the last time here. Y is less than positive 3 over 2x minus 2. 4 divided by -2 is -2. So we're going to go up 3 over 2. Up 3 over 2. Do that a few times. And this one is a dashed line as well. Okay, let's do everything that is above the yellow line, greater than here. Above the blue line, I mean. Shade that in yellow. And let's do everything less than below the red line. So below the red line would be all of this. Okay, so there's our shading, and we can see it overlaps here. So we erase this part and erase this part. And keep only this. This part is below the red line but above the blue line. Okay, that concludes the review. Make sure you can do this entire review on your own with no help, and then you'll be ready for the test. Good luck.